Good day. This is the fifth video in our series on naming organic compounds. In the first part, which was the first 4 videos, we looked at exactly how to identify the homologous series and a functional group to which a specific organic compound belongs. The organic compounds, or the homologous series, that is required in the CAPS document for grade 12 physical science are the following: the alkanes, alkenes, alkynes, haloalkanes, alcohols, ketones, aldehydes, carboxylic acids, and esters. You are supposed to be able to identify those different structures. Up till now, we identified the homologous series through identifying the functional group. Remember? We said we are going to handle naming the problem of naming the organic compounds by tackling it from the back. So the first part that we sorted out in a long name such as the one that is given over here is exactly how this name ends. Now we're going to look at the next part. The functional group is identified, but the functional group can be in more than one place on my carbon chain. And in the second last step in my naming over here, I identify exactly where my functional group in my carbon chain or in my organic compound is situated. Firstly, it's important to realize that there are some homologous series in which the functional group cannot be on any other place than the one that it's allocated. I'll explain later what I mean. In this case, it is not necessary to identify the position of the functional group. For instance, let's look at the alkanes. As you know, the alkanes does not really have a functional group because it's just identified by the fact that all the carbons are connected with single bonds. So in the case of the alkanes, we don't say exactly where the functional group is. The same goes, or there's an example, pentane. The same goes for the aldehydes. Now we know that the functional group for the aldehydes will always be at the end of the chain, so there's no way in which we can write it at the wrong place. So when we name an aldehyde, we'll just have pentanol without any indication of where the functional group is. The last functional group that we does not have to specify is the carboxylic acids, which is also at the end of the chain. Here you can see as an example, and the name of this carboxylic acid will be pentanoic acid. So what do I mean when I say the functional group can be in different places on my organic compound? Well, look at this example of an alkene. Over here, how do I know it's an alkene? Because I've got the double bond between the two carbons. But can you see in this example, the double bond is between the first carbon and the second, whereas in this example, the double bond is between the second carbon and the third. When we name organic compounds, we need to be able to specify exactly where the functional group is. In order to distinguish between these two compounds, we are going to number the carbons in the chain. Now, what do I mean by that? There are 2 different ways in which this carbon chain can be numbered. I start from one side, simply saying over here, this is carbon 1, 2, 3, and 4. But there's no specification to which side I start, so I could have just as well started from the other side and said, well, this is carbon 1, 2, 3, and 4. We had to decide on a correct way of numbering to make sure that all of us number in the same way. So the rule is going to be that the functional group must be as close as possible to the first carbon in the chain. If I look at my green numbering, it means that my functional group is going to be after carbon number 1. If I look at my red numbering, it means that my functional group is going to be after carbon number 3. Therefore, I know that the correct numbering is going to be the green numbering. According to the green numbering, the name of the organic compound will be but1-ene, which says that the functional group, the double bond O, is on the first carbon. If I use the red numbering, which is the incorrect one, then according to the red numbering, the name of the organic compound will be but3-ene, where the 3 indicates the position of the functional group. And what is the functional group over here again? It's the double bond O, which says that the functional group is on the third carbon. This is not the agreed upon structure. The structure, the rule says that the functional group must be as close as possible to number 1, or to the lowest possible carbon. So the correct way of numbering would be 1, 2, 3, 4, and the correct name for this compound would be but1-ene. The ene tells me to which homologous series does this carbon or this compound belong. And the 1 tell that is just in front of the last part tells me exactly where in this compound the functional group lies. Let's look at another example. When I look at this example, I can see that I'm now working with an alkyne. How do I know that? Because my functional group is a triple bond. This alkyne, this functional group, can be in more than one place. It could have been over here or over there. But in this case, it is between these two carbons. In order to find out exactly where it is, the first important step is that I number these carbons. So if I number it according to this way, I will see that my functional group, my triple bond, is situated on my second carbon. And the name for this carbon will be but2-ene. I could also number it in a different way, according to the orange numbering, making number 1 on this side. But if I number it in this way, you will see that my triple bond appears after the third carbon. If I look at the blue, the triple bond or the functional group is after the second carbon. And if I look from this side, on the orange, the functional group will be after the third carbon. So the name for this one would be but3-ene. What does the rule say? The rules say that my numbering must be in such a way that my functional group is as close as possible to 1. So I know the correct numbering or the correct name for this compound would be but2-ene. Okay, at this stage, I don't know how I got the but, but we'll get to that in the next video. Remember, we are working our way from the back to the front. What we have to know by now is where this -ine comes from. It's the homologous series telling me to alkyne. And where this 3 comes from, it tells me, or the 2, let's work with the correct example. Where this 2 come from, it tells me the position of the functional group. Okay, let's look at one more. What is this that I have over here? What is the functional group? There's my OH connected to this chain. What does this tell me? I know that I'm working with an alcohol. So I know that this compound over here is going to end with OL. So let's see how I can number this. If I number it from this side, 1, 2, 3, 4, 5, it means that my functional group is connected to the 5th carbon. If I number according to the blue numbering, 1, 2, 3, 4, 5, then my functional group is connected to the 1st carbon. Aha, which one is correct? Of course, the blue one, because I have to have my functional group as close as possible to number 1, or to the lowest carbon number. So if I name this, it's going to be pentan 1-ol, indicating that my functional group is on the 1st carbon. So why don't you see if you can correctly identify the correct names for the following in the revision exercise given to you. Good luck.